Hey, we've been over this before, but we need to go over it again because we really didn't name the process. We're finished with sponges and we're getting ready to go into the next phyla, which is Cnidaria, which is our jellyfish. And they actually have formation of tissue. Now, the process of forming tissue is called gastrulation. I am going to ask you that on a test, so make sure you know that the process of forming these layers, we talked about what the layers were, we talked about what they gave rise to, but the actual forming of layers is gastrulation. Like the process of forming a head is called cephalization. So, this process is the formation of tissues, and we have three basic tissue layers. Now, the periphery, our sponges, they did not undergo gastrulation. They didn't have tissue formation. They were multicellular. They had multiple cells doing different jobs, but they weren't coordinated into tissues. Now we're getting ready to see our first phyla that actually has tissue formation. Ectoderm. Ectoderm is the outermost layer of tissue. Remember, ecto means outside, dermis means skin, so this is going to end up forming your skin, your brain, and nervous tissue. In the middle, we have mesoderm. So mesoderm is going to be all of our middle tissue. It's actually going to form last. Ectoderm is first. Endoderm is actually second, so let's talk about it now. It's going to be the skin that during the process of the gastrula being indented, that archenteron, which is the space, remember the blastopore is the opening, the archenteron becomes the gut and the lining of the gut. So this is our inner tissue layer, and it's going to become the gut and the lining. So it forms second. And then lastly, we have the mesoderm. So it lies between the ectoderm and the endoderm. And when that mesoderm forms, it forms that middle layer of tissue, which is going to be our muscle, our bone, circulatory, reproductive. It's also going to be pulmonary, lungs. Sometimes, guys, when babies are premature, when they're born early, my son was born premature by 6 weeks. And when he was born, he had trouble with digesting his food. But he overcame that, and one of the problems later that he was showing in the days to come was with his breathing. And so he had to stay in intensive care for a little while because the breathing was the portion, the lungs were the portion of the mesoderm, and it's the last to be formed. And so when he was born prematurely, he didn't have a completely formed bronchial tubes, a pulmonary system that was um, enough to be formed well enough in babies that were born 6 weeks later. So in that last portion of a baby's life, all of these mesodermal systems are still forming, and they haven't matured enough to the point of what they would if they were full 9-month-old to term infants. So if a lot of these babies are born early, they may have to go to ICU. They may have to be put in an oxygen tent to help them breathe. Maybe maybe their bones or their reproductive or circulatory, maybe their heart. Maybe they have to be put on what's called ECMO, their heart machines, until they can completely mature enough to the point where they would naturally have been born. So sometimes premature babies have trouble with that. Now, the when the animals form these tissues, they're also, because the endoderm is the second to form, they have some sort of gut formation. Now remember, Porifera did not have a gut. What he had was called a central cavity. It was just a large cavity where the water came in from the intake pore and it exited through the osculum. But he was actually digesting food within an amoebocyte. When you have a true gut, there's two types. The two-way gut is the most simple of guts. In this type of gut, the animal only has one opening, and that opening is in the mouth. So food is going to come into one direction, and it is going to turn around, and it is going to exit in the opposite direction because it's coming in through the mouth. Whatever is needed is removed from the water. Remember, now we're going to be talking about jellyfish. But there is no exit, there's no anal opening, so that water is just going to turn around and exit through the same opening that it came in, which is the mouth. So animals that have a two-way gut, the food is coming in one direction and it is exiting in the opposite direction. Just think, it's coming in, it's turning around, it's back out, but it's going to be through the same opening, the mouth. So your incoming food is actually being mixed with the waste or the digestive food that is going out. Now, if animals have a two-way gut, and this is what we have, a one-way gut. This is what we have. The animal has two openings. Food is going to come in one direction, which is the mouth, and it is going to continue to go straight out the anal opening, so that is one way. Food enters the mouth in one direction and it exits in the same direction. So any animal that has a mouth and an anal opening is going to have a one-way gut. This is a lot more sophisticated gut than a two-way gut. So with our Cnidaria, they only have one opening, the mouth. This is our jellyfish. So they have a two-way gut. Now with symmetry, and we've talked about this a little bit too, but it bears repeating, symmetry by definition is just an orderly arrangement of body parts. And there's two types. If you have radial symmetry, the radial portion means the body part is arranging out from a central axis like spokes on a wheel. So think of your starfish. Now, our jellyfish are going to have this kind of symmetry as well. And I think I told you that with any animal that has radial symmetry, there is no formation of a head, which is called cephalization. So there is not going to be a brain or any sort of nervous tissue in that head-like region. Bilateral symmetry, this is where the body parts are mirror images of each other. If you cut the animal in half with an imaginary line starting from its head to the foot, each image is a mirror, each half is a mirror image. Porifera does not have symmetry, therefore they're considered to be asymmetrical. We're moving into Cnidaria now. Cnidaria will have radial symmetry. He will also have a two-way gut because there is a mouth, but there's no anal opening.